Good morning, everybody. We still have some people coming into the participants room. We'll wait another minute or two, and then we'll get started. Well, good morning, everybody, or good afternoon. Welcome to the University of Pennsylvania and the Water Center at Penn's panel discussion from New York to Philadelphia, expert perspectives on climate change impacts to the water systems in the Delaware River Basin. We're delighted to have you here. My name is Howard Newkrug. I'm the Executive Director, Founding Director of the Water Center at Penn. And I come to you following a full career of Philadelphia Water, 38 years, where I started as a staff engineer on drinking water and finished my career as the CEO and water commissioner of the utility. Next slide, please. For those of you who are not familiar with the Water Center at Penn, we are an applied research center focused on solutions to urban water challenges. We welcome collaboration with an entire Penn community, faculty, students, other organizations and centers, as well as with NGOs and other groups around the country. We would welcome, if you don't already know us, please reach out via our website. We have all the information here, our website, our social media, or send us an email, send me an email, and be happy to talk to you about what's going on and how you can get involved. Next slide. Moving on to the program, we have really, an incredible panel for you today. Each speaker will give a 10-minute presentation discussing the impacts of climate change on the Delaware River Basin and how those impacts are being addressed through changes in policy, planning, and operations. You will first hear from the perspective of the Delaware River Basin Commission, a regional body that oversees a unified approach to managing all 330 miles of the Delaware River across 4 states, New York, Pennsylvania, New Jersey, and Delaware. You will then hear perspectives from 2 cities at either end of this river. One is Philadelphia and the other one is New York City, on what they are doing to combat climate change and ensure that each of their cities has safe and clean drinking water. And finally, as a group, we will discuss not just the scientific and practical issues of managing climate change, but most importantly, why underprivileged communities often experience water-related climate impacts more acutely than other communities, and yet they have fewer resources for adaptation, and for making more equitable. How do we make more communities more equitable? I'll go ahead and introduce the 3 speakers to you now. The first speaker up is Kristen Cavanaugh, and she's the Deputy Executive Director of the Delaware River Basin Commission. She manages the Commission's technical programs, as well as developing and effectuating plans, policies, and projects relating to the water resources of the Delaware River Basin. Kristen has more than 25 years of experience in water resources management, modeling, and engineering. Prior to joining DRBC in 2019, she worked as a consulting engineer, leading this work in hydrodynamic and water quality modeling studies to evaluate the fate of pollutants in lakes, reservoirs, rivers, and coastal ocean areas. She is she's past chair of the Southeast District Pennsylvania American Waterworks Association, former president of the Philadelphia chapter of the American Society of Civil Engineers, and a member of the North American Lake Management Society. She holds a BS and a master's degree in civil engineering, environmental fluid mechanics, and hydrology from Stanford University, and she's a registered professional engineer in multiple states that include Pennsylvania and New Jersey. I think what you'll find is that all 3 of these of our speakers today have incredible backgrounds and are going to provide a lot of really great information. Our second speaker today is Julia Rockwell. She's a water resources professional with nearly a decade of experience working at the Philadelphia Water Department. Philadelphia Water is approximately 1.7 million drinking water customers and providing wastewater services to 2.3 million customers in the Philadelphia area. Julia has a diverse set of experiences at Philly Water that include project engineer for the Source Water Protection Program, a nationally recognized program that Philadelphia Water had developed much with Julia's support. Initiating development and implementation of a department's climate change adaptation program, which is where she works now, which is her main purpose for being here today, which is its mission is to reduce the risks and associated expenses PWD will face from the impacts of climate change by identifying and implementing effective and feasible adaptation strategies. A primary focus of Julie's work is to maintain the use of actionable climate change science in the utilities planning, designing, and decision-making processes. Julia holds a bachelor's degree in civil and environmental engineering from Bucknell and a master's of environmental management degree from Duke University. Alan Cohn is our third and final speaker, and he's the managing director of integrated water management at the New York City Department of Environmental Protection, where he leads initiatives to prepare water systems for climate change and population growth. His team spearheads partnerships and programs to reduce system demand, that's water system demand, protect critical infrastructure, and promote awareness and sustainable water measures in the built environment. These programs include a water demand management program that's designed to save by 2022, Alan, you don't have a lot more time, save 10 million gallons per day of water from the New York City water system. Alan serves as a senior policy advisor for water, wastewater, and solid waste on the mayor's special initiative for rebuilding and resiliency after Superstorm Sandy, and managed development of the New York City Wastewater Resiliency Plan, a comprehensive study to protect critical infrastructure. He currently represents New York City on the Water Utility Climate Alliance, a group of 12 large utilities which provide leadership and collaboration on climate change issues affecting the country's water agencies. And I know Julia and Philly Water is also a part of that group. Thank you all for being here, both the listeners and the speakers. We plan to have about 10 minutes speed talk from each of the panelists, and then we will open it up for questions. So please, if you have some questions, please feel free to put them into the chat room. In addition, just to let you all know that we are recording this presentation, and it will be made available. That's just for your information. If you have any issues, you should let us know privately. Okay, well, very good. Our first panelist is Kristen Cavanaugh, Executive Director, DRBC, and take it away, Kristen.
Thank you, Howard. So welcome to the Delaware River and its watershed. Next slide. From the mouth of the Delaware Bay upstream to the start of the river in Hancock, New York, the Delaware River runs for 330 miles. It is the longest undammed river east of the Mississippi, and it drains almost 14,000 square miles from its 4 basin states of New York, Pennsylvania, New Jersey, and Delaware. It's truly an interstate river in that if you stand on any bank of the river and row a boat across, you will land in another state. Over 13 million people rely upon the waters of the Delaware River Basin, and it's estimated to contribute over $21 billion in economic value per year. Total water withdrawals in the basin are about 6.4 billion gallons per day, and this includes significant out-of-basin exports to New York City and New Jersey. Next slide, please. The Delaware River Basin Commission is a federal interstate agency with responsibility for the management of the water resources of the basin. The DRBC was first formed in 1961 when the governors of the 4 basin states and the federal government came together to sign the Delaware River Basin Compact. It grants the full force and effect of law to be used as an instrument of the signatory states for them to manage the basin. They recognized that they had joint responsibilities, and the idea behind the DRBC was that this would allow them to achieve for the basin what they could not achieve alone. The commissioners include the governors of the 4 basin states, as well as the federal government, who's represented by the commanding general of the North Atlantic Division of the Army Corps of Engineers. Next. At the time the DRBC was created in 1961, there were 3 primary reasons for its creation. These were geopolitics, pollution, and flooding. So in the early 1900s, New York City's growth was spurring them to look for water outside their basin. And a 1954 Supreme Court decree amongst New York City and the 4 basin states granted New York City the right to export up to 800 million gallons per day out of the basin, and New Jersey up to 100 million gallons per day. These 5 entities are now referred to as the decree parties. The composition of the decree parties is similar to, but not quite identical to, the signatory parties of the compact. Next. Second, pollution was a serious problem in Philadelphia, in particular due to population growth and industrialization. So waste and sewage were discharged untreated and fish kills were common. Next. And then with respect to flooding, sorry, next please. Oh, pardon, you're good there. In 1955, there were back-to-back rain events resulting in what remains today the flood of record for the basin. It's referred to as the Great Flood, and it occurred in August of 1955 due to Hurricanes Connie and Diane. Next. So while the compact directs the commission to develop and maintain a comprehensive plan that addresses a diverse range of water resource issues from flooding to surface and groundwater supplies, recreation, control of the movement of saltwater, and regulation, our core responsibilities can be summed up as ensuring an adequate, sustainable, and resilient flow of clean and healthy water. Essentially, you focus on water quantity and water quality. Next. We do this through implementation of our water resources program, which includes a variety of programs that are implemented via tools such as planning, modeling, monitoring, assessment, data analysis, regulations, and other types of planning studies. For all of these studies, we must also, in work that we do, we must also consider the immediate and long-term effects of climate change, as well as who our stakeholders are and how they are impacted. From a technical perspective, we have already begun incorporating climate change considerations into our work in our water resources program in several ways. A few examples are that we have incorporated sea level rise analyses in evaluating future flow and reservoir management scenarios as part of our operations work. We've also recently developed and begun using a 3-dimensional computational fluid dynamics model to consider the effects of sea level rise on drought management. This model has also begun to be used to assess salinity concentrations in the tidal portion of the river, and that will allow us to get a more detailed understanding of how salinity changes may impact aquatic habitat as well. We've also considered climate change effects in our hydrologic modeling to better understand the impacts of future hydrology on water availability. And we're developing more sophisticated models that will also allow us to incorporate and downscale data from global climate models. In conjunction with a separate planning effort to project future water use demands in key sectors such as potable water supply, industrial, power, and agriculture, we can then look at future supply versus demand to evaluate the sustainability of future water availability. As a last example, the USGS had previously developed a decision support tool to evaluate the effects of flow changes on critical aquatic habitats in the upper Delaware headwater area. And we are working on updating that tool and incorporating an air temperature component so that we can also use it to evaluate the future climate change impacts with respect to changes in air temperature on habitat. And that will be useful in terms of informing adaptation planning. Next slide. The climate change risks that we face are similar to those that Julie and Alan will highlight in more detail in their presentations. Our work to date, though, suggests that sea level rise and its impact to salinity in the estuary most likely poses the greatest climate impacts in the basin related to drought management and water availability, which is related to one of our core responsibilities of flow management. Mean sea level has risen about 1 foot over the last 100 years and is predicted to continue to rise at an accelerated rate. Next slide. So one area I'd like to highlight in my short time is with respect to climate change impacts on our flow management. So this is a core responsibility of the DRBC, and it's critical in understanding how the water supply needs of New York City and Philadelphia are tied together by the management of the Delaware system. Although the river is free flowing for 330 miles, its management is complex. As part of the 1954 Supreme Court decree, New York City is able to export up to 800 million gallons per day out of the basin from its 3 reservoirs in the upper Delaware. And these are shown on this schematic in light blue on the upper right-hand side. There are also 5 Army Corps reservoirs in Pennsylvania in the dashed red box, and several hydropower reservoirs throughout several of the basin states. The river is non-tidal north of Trenton and tidal south of Trenton, meaning that the management of the river is affected not just by the flow coming down the river, but also by downstream conditions in the bay and ocean, such as sea level rise. Next. There is a minimum flow target or flow management objective at Montague that is managed by the USGS Office of the Delaware River Master, which was created by the 1954 Supreme Court decree. Under normal conditions, New York City is responsible for meeting a flow target at this location of 1,750 CFS via directed releases from its 3 reservoirs at the headwaters of the Delaware. These are Cannonsville, Papacton, and Neversink. Next. There is also a minimum flow target at Trenton that is managed by the DRBC. And under normal conditions, the Trenton flow target is 3,000 CFS and is met via directed releases from Beltsville and Blue Marsh reservoirs in Pennsylvania. These are Army Corps reservoirs in which DRBC owns water supply storage. Next. So as I noted, flow management under normal conditions is based on directed releases to meet the Montague and Trenton flow targets. However, the DRBC also has a basin-wide drought management plan that is based on the storage in the 3 New York City reservoirs, which are 3 of the largest reservoirs in the basin. So if the combined storage of the New York City reservoirs drops below certain levels, as shown in the graph on the right, the flow objectives and the New York City, New Jersey diversions are reduced in a phased manner to conserve water. And under drought emergency conditions, shown on the red line on the plot on the right, the flow objectives also vary based upon the location of the salt front. So what is the salt front? The salt front is where fresh water from upstream and salt water from the ocean become well mixed. And for the purposes, there's not like a specific place where you can see the salt front. It's a gradual transition. But for the purpose of defining exactly where the salt front is, we define it as the 7-day average chloride concentration of 250 milligrams per liter. So the plot on the left shows in a shaded area that's sort of a purpley blue color where the median monthly salt front location is located. The goal of the flow and drought management plans is to provide sufficient fresh water from upstream to keep the salt front safely below drinking water intakes in Philadelphia and Camden, as well as to protect industrial and power withdrawals in this tidal portion of the river. In the 1960s drought, before the DRBC developed its drought management plan, the salt front reached river mile 102, which is highlighted in red on the plot on the left, or the plan view on the left. And this resulted in almost $20 million of economic damage in today's dollars. Although it did not reach the drinking water intakes at river mile 110, it did come very close. The DRBC also has a lower basin management plan that is based on elevations in Beltsville and Blue Marsh reservoirs. Next. So the reason I go through all this to talk about our flow management plan is in part to demonstrate the relationship between New York City and Philadelphia's water supply resources, and also to show you one specific example of how we are thinking about climate change and sea level rise. So this plot, which our manager of water resource operations, Amy Shallcross, can be credited for. She calls it the worm or the wormies plot. So on the left-hand side, using our 3-dimensional hydrodynamic model of the river and estuary, we can use that to predict the location of the salt front. The plot on the left shows a 4-month period in 2002, which was a very low flow period, and what the range of the salt front was in orange there. And that's under current conditions. The other 4 plots show where the salt front would have been under a range of sea level rise conditions ranging from 0.3 meters up to 1.6 meters. And this is within the range. It's representative of what future scenarios might be. So without additional flow from upstream, the salt front would be predicted to extend as far up as River Mile 104 compared to where it was in 2002, down around River Mile 90. So this highlights the challenges that we face in the future with managing water quantity and balancing the needs of upstream and downstream users, as well as water quality, since increased salinity may make water treatment for public water supply, industrial, and power use more difficult and costly, and could also adversely affect aquatic habitat as well. Next slide. So in addition to our technical work on climate change impacts, we have also launched an advisory committee of climate change. The AC3, as we sometimes refer to it, had its inaugural meeting last month and brings together experts from diverse stakeholder groups to advise the DRBC. I'm pleased and proud to say that Howard and Alan and Julie are all members of the Advisory Committee on Climate Change, and Howard is actually our inaugural chair. So thank you to all 3 of you. The purpose of the AC3 is to help the DRBC identify and prioritize threats and vulnerabilities, develop science-based future planning scenarios, and serve as a coordinating body for climate-related basin, water resource, and watershed studies. We are looking to the committee to provide valuable input to the DRBC. Next slide. As we move forward, we are also looking to be more thoughtful in incorporating diversity, equity, inclusion, and justice into our daily work and long-term strategies. Earlier this year, we convened an internal DRBC work group to develop a draft DEIJ strategic plan for the commission, to provide recommendations for DEIJ training for staff in the near term, and to examine and expand our current outreach efforts to include underserved communities. These efforts also align with input that we've already received to date from our Advisory Committee on Climate Change members, that we intentionally build equity and justice considerations into our priorities. Thank you.
Great. Thank you, Kristen, for setting the stage and providing all that helpful context on the Delaware River Basin Commission. We're now going to shift focus to the City of Philadelphia and the Philadelphia Water Department. Next slide. Just to make sure we're all aware of the scope of services that PWD provides to the City of Philadelphia, we are a one water utility, meaning that we don't only provide drinking water services, but we also provide wastewater and stormwater services. And as you can imagine, providing all these different services requires an extensive amount of infrastructure, some of which I have listed on this slide. On the drinking water side, we get our drinking water from the Schuylkill and Delaware rivers, and we have 3 major drinking water treatment plants. And on the wastewater side, we also have 3 major wastewater treatment plants. And between the 2 service areas, we have thousands of miles each of water and sewer mains. On the stormwater side, we're most well known for our Green City Clean Waters program, which is our largely green-based approach to manage stormwater and reduce combined sewer overflows, or CSO, which will improve our surface water quality. Roughly 60% of the city is served by a combined sewer system, and the other 40% is served by a separate sewer system. And I'm showing this map on the right-hand side to just make the point that it's important to consider where Philadelphia is located in the context of the entire 13,500 square mile Delaware River watershed, and also the Schuylkill River watershed, our other drinking watershed. We are located at the very bottom along the tidal Delaware River, and so our source water protection efforts are critically important, as are our efforts to collaborate and coordinate with entities like the Delaware River Basin Commission. Next slide. The work we do to achieve our mission as a one water utility can generally be boiled down into the 4 main phases shown here. of understanding impacts to our systems, analyzing them, planning for them, and then implementing strategies. And we do take a lot of pride in the fact that our work is based on data and the best available science. We use that information to build sophisticated tools, namely models of our infrastructure systems, but also models that function on watershed-wide scales and basin-wide scales. These models help us understand how our various systems perform under a range of current and future conditions. We use information from those models and tools to inform our comprehensive watershed-wide planning approaches, where we really evaluate our risks at a high level of detail and come up with strategies to reduce those risks. And we try and employ innovative strategies to reduce risk whenever we can. And innovative strategies can mean many things. It can mean adaptive management, it can mean policy changes, using advanced technologies, and also being very active in bilateral and multilateral networks and partnerships. Next slide. With all of the climate change impacts that frankly we are already experiencing in Philadelphia, our department knew that we needed to view all of our programs and our planning processes and our operations and management strategies through this lens of climate change. Next slide. To that end, we developed a climate change adaptation program known as CCAP in 2014. We are building off of the work that actually our city, through our Office of Sustainability, initiated with release of the city's first climate change adaptation plan in 2015, which I'm showing on the slide here. And our program goal, as Howard already stated in the introductions, is to reduce the risks and also the expenses our water utility will face from the impacts of climate change by identifying and implementing effective and feasible adaptation strategies. And the climate change impacts that we are going to experience in Philadelphia and in the region are listed on this slide. So we can expect to see more precipitation in the future, higher sea levels, higher air temperatures, more extreme storm events. And the science is a bit iffier on drought, but we do continue to track that science. And we look forward to actually collaborating a lot with the DRBC on this issue as it relates to climate change. Next slide. With all these climate impacts, we as a One Water utility face a number of different risks. A few of our priority risks are shown on this slide. We are concerned with various types of flooding. So we will experience coastal flooding, which is driven by sea level rise and storm surge because of our location on the tidal Delaware River. And with increasing precipitation, we'll see more riverine flooding and infrastructure-based flooding, which is a term that just refers to conditions in which the capacity of our drainage system is exceeded. And we see flooding either in basement homes or in streets in different neighborhoods. And this gift on the left-hand side is going through 1 through 7 feet of sea level rise in the vicinity of one of our wastewater treatment plants. We also have many different potential water quality impacts that we could experience from climate change. As we see more rainfall, we will see more runoff, which will degrade our source water quality potentially. And with higher air temperatures, we'll also see our surface water supplies increase in temperature, which could lead to other degradation issues, algal blooms being one of them. This image on the lower right-hand side is not algae on the Schuylkill River. It's actually a harmless plant called duckweed. But the point is that as air and water temperatures rise, we will start to experience more water quality impacts. Next slide. And as Kristen already mentioned, for our community in Philadelphia, one of the biggest water quality concerns we have has to do with salinity intrusion that will be intensified by sea level rise. And so Kristen already walked you through the map I have on the right-hand side, but I want to point out that our team has honed in on what we're calling our primary sea level rise planning scenario. This is a scenario we won't only be applying to salinity modeling, but also to other planning initiatives throughout our department. And it comes from a 2017 report by NOAA. And for Philadelphia specifically, their intermediate high scenario indicates that we could see around 6.4 feet of sea level rise by 2100. So that kind of gives you an idea of the numbers that we are primarily working with. Next slide. Soon after our program was initiated and we had taken stock of all the major risks we're facing, we quickly realized that we needed to develop a lot more actionable science and information to actually comprehensively evaluate our risks. And if you click forward, Actionable science can be defined as data, analyses, projections, or tools that can support decisions regarding the management of the risks and impacts of climate change. So basically, how do we take the climate science that is readily available to us from these global climate models and make them relevant on not only a local scale, but also in terms of the work that we do at Philadelphia Water Department. Next slide. We have done the most work related to analyzing sea level rise projections and also precipitation projections. So I'm going to walk through some of that information now. Some of the risks we're facing from sea level rise, I already briefly mentioned. So flooding of our major assets, both assets that are at surface or above grade and assets that are below grade. We also, again, could see degraded source water quality from salinity intrusion and experience an increase in energy demand for additional pumping and also treatment. If you click forward. So to address these risks, our program has developed a suite of different tools and information that we are hoping our planning and design groups throughout the department will be able to easily utilize. Some of the examples of our actionable tools are listed here. Our team did a really deep dive into analyzing sea level rise projections for Philadelphia and also storm surge elevations on the Delaware River. We then applied that information to a customized GIS screening tool to evaluate the vulnerability of our assets. We've also recommended a proposed design flood elevation based on both current and future flooding risks for our infrastructure systems. And another planning and modeling group within the water department has developed a 3D model of salinity that we are using to analyze salinity intrusion under both current and future sea level conditions. Next slide. I just wanted to provide some more information on one of these tools, which is our GIS screening tool. This image on the screen is showing the footprint of our Southwest Water Pollution Control Plant. And if we click forward, I'm taking you to the 2060s, when based on our primary planning scenario, we could expect to see around 2.89 feet of sea level rise. And you can see that this permanent inundation is not yet causing an issue at our plant, if you click forward. But if you consider storm surge on top of that permanent inundation from sea level rise, this is showing storm surge for a 100-year storm event. We start to see flooding vulnerabilities over a large portion, if not the majority of our facility. If you click forward, we'll go to the year 2100, where we can potentially see around 6.4 feet of sea level rise. And clearly you can see that most of our plant is at risk of inundation. And I just want to stress this would be permanent inundation because sea level rise is a constant change in that water elevation. If you click forward one more time, as you would expect, if we add 100-year storm surge on top of that, the flooding is only exacerbated. Next slide. So I'm now going to just quickly shift gears to precipitation, because this is another big climate risk that we're facing. In Philadelphia, we can expect to see more intense rainfall in the future. And through our analyses, we also determined that the largest storms are projected to increase the most, which is not good news for our infrastructure systems. Potential risks for us include that we could see more frequent combined sewer overflows, or CSOs. We could see increased erosion and sediment transport, which could degrade source water quality, and an increase in riverine and infrastructure-based flooding. The primary issue with precipitation projections and why they're not usually immediately actionable for water utilities, especially stormwater utilities, is that the resolution is not high enough for us to plug into our hydrologic and hydraulic, or H&H models, and some of our other modeling tools that we would really use to comprehensively characterize risk. So our team embarked on a pretty extensive journey to develop high resolution precipitation projections that we can directly plug into those modeling tools. We also have created future design storms. Design storms are a common infrastructure based design tool. So we've developed some metrics for those storms for the future. And we have a stochastic rainfall generator, which is a tool that allows us to explore current and future variability in rainfall. Next slide. So going through the details of what our method entailed and how we got to a point of developing high resolution projections would be a separate presentation in and of itself. But if you're interested in getting into some of the technical details, we do have a publication in the ASCE Journal of Water Resources Planning and Management And I'll provide a link to that journal article at the end of my presentation. Next slide. So the question our program is facing now is, now that we have a critical mass of actionable science and information, how do we actually use that information to adapt? Next slide. And our program's primary strategy right now is to really mainstream the use of this climate information into our existing planning and design processes and our operations and management strategies. So we want to ensure that existing assets are protected to future climate change impacts, and that any new assets being planned and designed are considering the future that climate change will bring to bear on our city. We have several projects underway in this vein of mainstreaming climate information. Our team is performing on-the-ground risk assessments at all our facilities that are vulnerable to coastal inundation to better understand how we need to protect those assets and what investments we may need to make. We also regularly coordinate and inform staff that are involved in our long-term infrastructure planning efforts on the water and wastewater side of things. And we're also starting to have conversations with our stormwater planning teams. We are integrating this information into our capital planning process. And our highest priority right now is to develop and implement a set of climate resilient planning and design guidance that would apply to all of our systems, so drinking water, wastewater, and stormwater systems, and provide our planners and engineers with a user-friendly roadmap that tells them what climate change projections we think make the most sense for them to use in their work based on all the research and the work that we've done. Next slide. I would be remiss in talking about climate adaptation if I didn't mention one of our biggest examples of adaptive management. So it's not like, you know, our program's thinking on adaptation started with the inception of our program in 2014. The department has been thinking for many, many years about how we can adapt to changing environmental and climatic conditions and maintain our levels of service. And one of the biggest success stories has been this Green City Clean Waters program, which is our largely green-based approach to reducing CSOs. And the primary reason that we on our climate adaptation team view this to be such an adaptive approach is that green infrastructure is made up of many smaller and discrete systems, which you can see by this map in the middle of the slide. So because we're working with all these decentralized and discrete systems, as climate conditions change, we can adapt how we plan and design those systems. And that is something that's a lot harder to do with gray infrastructure like tunnels and tanks, because once that infrastructure is built and constructed and in the ground, it's a lot harder to adapt to changing conditions. Next slide. I'll just wrap up by saying our program is really focusing right now on those priority initiatives I mentioned to mainstreaming the use of climate information and figuring out ways we can effectively move from more of a planning phase with our work to more of an implementation phase. We also continue to build internal capacity on this topic and engage with city and regional partners wherever possible, because resilience really is a regional issue. It's not just a local issue. And I would say also one of the biggest kind of positive impacts on our program and kind of helping us direct the work that we're doing has been our involvement in the Water Utility Climate Alliance, known as WUCA. And I'm showing the members of WUCA on this map here. We're made up of 12 of the nation's largest water providers. And because adaptation is really a relatively new field for water utilities, it is really critical to have this type of forum to exchange ideas and learn about best practices and lessons learned from one another. So if we go to the next slide, you'll see that I have a link in this list to the WUCA website. I strongly encourage you to check that link out. And I'll leave it there. Thanks so much for your time.
Well, thank you, Julia, for your presentation. We're always very interested to see what Philadelphia is doing. New York City has a lot in common with Philadelphia when it comes to both climate change impacts as well as our resiliency. And as Julia said, we're always looking to understand what others are doing and learn from each other on this emerging topic. Next slide, please. So New York City Department of Environmental Protection, or DEP, is the largest combined water and wastewater utility in the United States. We have an annual budget of more than $1 billion. We spend that on protecting our watershed, that delivers almost 1 billion gallons of water per day to New Yorkers. We protect an approximately 2,000 square mile watershed, including 19 reservoirs and 3 controlled lakes. We also operate and maintain our wastewater system, including stormwater management, treating over 1 billion gallons per day of wastewater through our 14 wastewater treatment plants and 96 pumping stations, and maintaining over 7,500 miles of sewers. That all discharges into the Hudson River and New York Bay. And finally, we're also responsible for air noise and hazardous waste, but I'm of course going to focus on water today. Next slide, please. So this is a visual of the New York City watershed. On the left, you can see the Catskill and Delaware watersheds. The Delaware watershed is to the west and of course drains into the Delaware River, whereas the Catskill to the east drains to the Hudson. We also have the Croton watershed, which is the oldest of the 3 watersheds. Whereas the Catskill and Delaware watersheds are an unfiltered supply, the Croton watershed is a filtered supply, and we tend to rely mostly on the Catskill and Delaware watersheds because of the higher water quality, as well as the lower energy intensivity for treating and delivering that water. On the right, you'll see the conveyance infrastructure that gets water from the aqueducts from the watersheds into the city, and we're always looking to increase the redundancies in the system in both the watershed as well as the distribution system. It's really key that if one part of the system is to go down or be affected by an event, being it natural or man-made, that we have the flexibility to tap into other parts of the system. Next slide, please. So climate risks in New York City have been pretty intensively studied, in particular since about the mid-2000s, working with the New York City Panel on Climate Change, which I'll talk about in just a minute. The climate risks are including, but not limited to, some of the same risks that you heard about from Julia, including drought, heavy rain, sea level rise, coastal flooding, extreme heat, warmer winters. And we can't look at climate impacts in isolation. We have to look at social vulnerability as well, and that's what you see on the map on the right. The Centers for Disease Control utilizes 15 indicators characterized into 4 themes: socioeconomic status, household composition and disability, minority status and language, and housing and transportation. And that shows a lot of New York City showing high social vulnerability. When you look at the impacts of climate change on these communities, Northern Manhattan, Hunts Point, Sunset Park are a few that the New York City Panel on Climate Change is focused on. You see compounding impacts from heat events with high incidence of asthma, with a legacy of industry in the same locations where you have potential for coastal flooding. And so it's really important to consider these impacts together and to help focus our adaptation measures to really try to help the most affected communities. Next slide, please. So as I mentioned, the New York City Panel on Climate Change provides an authoritative source of information for climate change for the city's decision-making. It's convened in 2009 and consists of scholars and scientists. The 2019 report is the latest and addressed many of the impacts that I mentioned, as well as community adaptation and equity. And a new leadership team and panel members were appointed just this year in June, with the goal of releasing the first in a series of MPCC4 products as the 4th assessment report, starting in late 2021. Next slide, please. So we've heard a lot about temperature, and this is just a way of seeing that temperature is rising. And if you look at the longer term trend, the line isn't quite as steep as that if you look at the shorter term trend. So starting about in the 1970s, we see an uptick in the trend. We have temperature rising in an average of 0.2 degrees per decade, which doesn't seem like a lot, but adds up over time. It also exacerbates our susceptibility to heat waves. And the projections and the models from the New York City Panel on Climate Change suggest we'll see an increasing number of heat waves moving forward, as well as a decreasing cold days, which is important for our snowpack, which I'll talk about in a few minutes. Next slide, please. Extreme rainfall is increasing. This is showing rainfall trends at Central Park since 1900. You also see an increase with a shift around the 1960s, 1970s. In the 1960s, you can actually see the drought of record that was referenced before, but then you see highly variable weather conditions with years above 80 inches of rain, all the way down to around, below 40 inches. We were seeing a lot of that rainfall falling in these heavier events. The heaviest 1% of daily rainfall events have increased by 70%. That means those days those very, very wet days are increasing. However, we have had historical droughts. If you look back further than this in the drought record, we've had 8 historical droughts lasting 5 years or longer. And while the science, the projections do not give us too much guidance, we do anticipate that drought is still in the mix, and we need to plan for it. Next slide, please. This picture shows one of our reservoirs in 2001. Although, again, precipitation is expected to increase, the city needs to analyze and plan for drought patterns and changes in temperature that may lead to decreased snowpack and longer growing seasons that reduce the availability of water to refill reservoirs to meet summer demand. We not only need to meet the city's drinking water needs, but as you know, we need to meet our releases into the Delaware River, as well as supporting fishery habitat and recreation, generating electricity, and further enhancing flood mitigation in downstream communities. Next slide, please. 10 years later, this picture is from 2011, where we saw tropical storms Irene dumping 16 inches of rain in some parts of the watershed, and then just 10 days later, we had Tropical Storm Lee. We maintained an adequate supply of high quality drinking water this entire time, but it did lead to an unprecedented treatment regime, 260 days in order to maintain that high quality water. This risk too, this risk we understand a little bit better than drought, which we do anticipate to increase in frequency in the future. Next slide, please. One of the other risks, as I mentioned, is temperature decreasing, the snow melts. We expect a shift in stream flow, which can affect turbidity in our system. It can also affect, as I said, the ability of our reservoirs to fill in time for the peak summer demand, and have repercussions for aquatic species and water supply reservoir management. This picture is from the National Climate Assessment, is showing that the timing of stream flow has changed in the historical record, and is expected to continue to change in the future. Next slide, please. So one of the first lines of protection is our watershed protection program. We have a natural system, essentially our original green infrastructure program to protect the land around our reservoirs and maintain water quality such that we can avoid building a large filtration facility. This is a portfolio approach, and this is something that we'll see as a common theme with climate adaptation, is that there is no silver bullet. You have to look at infrastructure fixes, management, partnerships, and different ways to invest in the system to respond to changes. And this is an adaptable approach as well. The last filtration avoidance determination was made in 2017, and this is something that we continually have to monitor and revise to make sure that we continue to maintain the highest quality water possible. Next slide, please. And so shifting gears to sea level rise, and which is a large focus of this group, the New York City Panel on Climate Change has similarly done a lot of analysis over the years to look at the impacts, particularly to New York City. A mid-range estimate for the city shows 11 to 21 inches by the middle of the century. But if you start to look out towards the end of the century, these scenarios start to diverge, and we have a lot more uncertainty about the higher end projections, including an Antarctic rapid ice melt scenario shown in the hatched yellow and red, which really is one of the more daunting scenarios. It's what's referred to as high impact, but low probability. Next slide, please. And so Julia showed the climate resiliency design guidelines. We're taking steps right now to respond to these potential impacts. The yellow dots show, or rather the green dots show our wastewater treatment facilities, and the yellow dots show our pumping stations, which are all vulnerable to sea level rise. And we're currently designing these facilities to be flood proofed and raised above the floodplain with sea level rise wherever possible. We did a study on the next slide in 2013, right after Superstorm Sandy, that showed that with sea level rise, there's about $1 billion of assets that are at risk by the middle of the century. If you keep clicking, you'll see that the cumulative risk over 50 years goes up to over $2 billion from repeated flooding. And if we invest about between 300 and 400 million now, we can avoid a lot of these risks. We currently have received $160 million towards implementation of this plan, and we continue to implement as new capital projects arise to align with our design standards. And one of the big takeaways from this is that investing money now can help us avoid the worst case scenarios in the future. Next slide, please. I'm not going to talk about WUCO too much because we're running out of time, and Julie already mentioned it. But the idea is that we can work together to understand how we as water utilities can enable more thriving communities and make sure that we can maintain the sustainability of our cities. Next slide, please. And so finally, resiliency, again, there's no silver bullet. There's many layers, including but not limited to planning flexible and redundant infrastructure, design standards, and retrofitting at-risk infrastructure, protecting natural assets and promoting best management practices. And last but not least, adapting our approaches and learning from our peers. So finally, you'll see a couple of links to some of the resources I mentioned. And with that, I think we can open it up to the panel.
Oh, great. Thank you. Thank you so much, Kristen and Julia and Alan. That was so much information, and you know, I just learn new things every day, and thank you for being part of that for me today. We do have a few minutes for some questions, and I will ask the first one, and then anybody in the audience who would like to ask a question, put it into the Q&A section, and if we don't get to it, we will follow up. We will follow up with providing some sort of answer to you as best we can. I guess my first question is I'm watching what you guys are all doing, and it's so complicated. And you're using these hydraulic models and all this work with climate change, and we're predicting large-scale changes in our environment. And we're then putting all this into aspects of planning and design and construction, and when we look at it, it's not like every location is as critical as the next. And one of the areas, you know, we've had a lot of discussions of late about disadvantaged communities, and I'm very curious as to is there something special? Is there something different that we should be doing for our low-income communities, communities of color, and other areas? And I'd like to just open that up and maybe just call on Julia to take the first crack at that.
Sure, yeah. I mean, from my perspective, I think one of the biggest things we can start doing is thinking about how existing programs and policies can integrate equity, and the fact that climate change will really just exacerbate what we already see in terms of inequalities throughout our city. One example I often point to is that we've looked at average surface temperature data, we being the City of Philadelphia and our Office of Sustainability, over the entire city, and some neighborhoods are almost 22 degrees hotter than other neighborhoods. And then if you overlay census data on that, you see that those hottest communities are often the lowest income communities and communities of color. So how can we, in our role as a water utility, think about these vulnerabilities of different neighborhoods in the context of what we do? And green infrastructure immediately comes to mind. So our primary driver has been to implement green for our CSO regulations, but can we integrate into that planning process other drivers, including and especially things like heat island effect and vulnerabilities that these communities are frankly already facing and struggling with.
Great, thank you, good answer. Kristen or Alan, do you like to add to this?
Sure, I can chime in. So I think incorporating and engaging with socially vulnerable communities and low-income communities from the start is really key. There's a perception, that the New York City Panel on Climate Change has documented that decisions have already been made by the time that engagement occurs. And so one of their recommendations is for early engagement. We, as decision makers, need to incorporate into, the more technical processes, as well as cost benefit analyses. When we're looking at avoided damages, for instance, you're going to tend to favor the communities that have higher property values. But when you start to incorporate other metrics, that starts to tip the scales a little bit. We're seeing some of that. For example, there was a recent New York Times article in Houston about incorporating some of these other factors into the decision-making process for responding to some of the flooding issues that they're having there. And again, when you start to engage with communities, you start to learn that it's not just green infrastructure, it's not just coastal protection. There's building schools, safer streets, greening spaces, creating cooling centers. There's a mix of infrastructure approaches other than the ones that we are used to dealing with as water utilities, and you have to look at this holistically.
Thank you. Hey, Kristen, TRBC is a large organization representing a very large area. How do you hope to bring in these disadvantaged communities into these discussions in a real way that allows us to consider them in our planning?
So the DRBC currently has a couple of avenues for public participation. So we have, established public hearings when we make policies, and that information's on our website. We also have, advisory committees. I mentioned the Advisory Committee on Climate Change, and we have several. But I would be the first to acknowledge that if you look at the composition of our advisory committees, you won't see a lot of diversity in terms of some of the organizations that are involved or the participants on the committees. And I think there's a big opportunity for us there to more proactively reach out, whether it's through our networks or through collaborating more with existing NGOs and others with connections with disadvantaged communities, to be able to get that perspective, kind of like Alan alluded to, not on the back end when the policies come up with and you're presenting it to the public, but really at the beginning of the planning stages. We're certainly, with the formation of our internal work group and development of a DEIJ strategy, looking to do a better job of that. And I would say as well, with respect to our communication and outreach surrounding, even our public hearing, it's a pretty formal process of how that's noticed in the Federal Register and, various other steps that we take to try and be transparent. But if you're not plugged in to what the DRBC is doing, you still might not know really what's going on. So I think we could do a much better job of communicating earlier and with a broader audience.
Great, thank you. Another question is about barriers, and the biggest barriers that you feel you're all facing towards both short-term and long-term solutions. And some of the whoever asked this question suggested things like, is it will or motivation? Is it financing and funding? Is it a scientific knowledge? And And Kristen, you're still up on the screen, so I'll ask you first, what do you think is the biggest barrier to forward progress here?
You know, I have a fairly short tenure at the DRBC, and so I'm coming at a bit of a sort of an external lens with some things as well. But I think as a federal interstate commission, one of the barriers to our work, it's a challenge, it's not insurmountable, but really is getting together 4 different states and the federal government to get them to agree on how they want to approach a particular topic, whether it's a regulation or policy or, you know, advancing certain research, and recognizing that we're all part of the watershed, but concerns are very local. So if you talk to people who live in the upper Delaware, their concerns are very different than those who live down, you know, hundreds of miles downstream. So just trying to really identify priorities and try and recognize that it's a lot of balancing of different valid concerns and needs amongst a lot of different, you know, members of that watershed community.
Yes, I remember in the past there was some states that wouldn't admit to the whole action of climate change, which made some of the discussions I had a decade ago somewhat difficult with, I see that as a real barrier. Alan, do you have a thought on this?
Yeah, I mean, it's always, you know, we can always point to the science and say that there's uncertainty, but the direction is pretty clear, that, you know, temperature is trending up, sea level is trending up. You know, I think some of the things that we need to focus on now are getting on the same page in terms of what information we're using, in terms of what we expect to happen and when. So I think the dial has really moved on the science to the point where we can't necessarily say that the uncertainty is reason enough for inaction. So I think we are moving away from pointing to the scientific uncertainty. And there are resources, on the table, perhaps not enough for planning and modeling and community engagement, which we just talked about. There's a lot in terms of regulatory compliance and capital infrastructure. Of course, we have financial hardships at the moment, and it may have some more in the future. But I think key to this is looking at each one of those dollars that we spend and seeing how we can look at it through the lens of climate change that Julia referred to.
Excellent, thank you. And Julia, do you want to close it up with some thought on your greatest barrier every day when you go into work or go to your office?
When I sit in my apartment working. Yeah, I mean, when Kristen was talking, I was just thinking, she was speaking to the coordination at a basin scale, but I think that for cities around the country and really globally, this issue of coordination is also a really big challenge, just in terms of understanding what governance structures are going to be the most effective to move the ball forward on climate resilience, because there's no one agency that's going to achieve it, or one entity for any city or any region. It's going to have to be all your different utilities in coordination, energy, water, transportation, and the list goes on. So how, climate change is really forcing, I think, conversations about just how, in terms of governance structure, can we be most effective, and just really leverage all the existing resources we have and all the existing expertise we have as separate agencies, and make sure that we're really making meaningful strides towards adaptation. Well,
thank you. And thank you, Julia, and thank you, Alan and Kristen. I think it was a great series of presentations, and we only have a little time for questions and answers, but there are more questions that have come in, and we will send them out to each of you to try to get some answers for what has been asked. And if any of the other people who are on the line who want to ask a question, please feel free to throw it into the Q&A or send us an email. We'll be happy to work with you. And with that, again, thank you, and thank you for Andrea, and for Meg behind the scenes here making this whole thing work. And hope to see you all in person sometime soon. Take care now. Bye-bye.
Great. Thank you, everyone.
Thank you.